Hi friends, today I am going to brief you about pumps in this video. Generally if I say pumps, what will be coming to your mind? I think most of these people mind goes to home because we will be using this pump to draw water from underground and we will be storing in the overhead tank. Now you came to know the basic understanding of a pump and its usage. So now let us look about what is a pump. See what is a pump. We can see what is a pump in this side photo. This is generally a normal example of a pump. See, pump may be defined as a device which is used to transfer liquid from one place to another place. So this may be defined as a device. We can consider this with the previous example. One place means underground, another place means our overhead tank. So pump is a device which transfers liquid from one place to another place. This you understand clear? So it moves the fluid from low pressure to high pressure by adding energy. See, generally we will be knowing that material will move from low energy to higher energy, low pressure to higher pressure. So in this, the material is moved from low pressure to higher pressure or lower energy to higher energy by the pump's mechanical action. So we will be knowing about the basic principle of this pump. See, the basic principle of the pump is that vacuum is created in the inlet of the pump due to pump internal operation, and the pump pushes the liquid into discharge side. So this is called a suction, this is called the delivery, this is called the delivery, this is called the suction. DC, the we will be saying the vacuum is created due to pump internal action is due to that this action, this mechanical device called as impeller. This is called as casing, this is called as motor, this is called as drive shaft. So due to the pump internal rotation, means due to the presence of this impeller blades arrangement, vacuum is created in the suction and the material is pushed to the delivery side. Generally we will be denoting a phone by its maximum RAM capacity, denoting a bike by its maximum efficiency, maximum mileage. But how we will be defining or rating a pump? So we will be rating a pump based on its maximum pressure and maximum flow that it can give at a defined speed. So we generally pumps will be rated by these two terms. Okay, now we have completed what is a pump. Now we'll be going through different types of pumps. Pump types. See, pumps are basically classified into two types based on their working principle. So the two types are rotodynamic pumps and positive displacement pumps. Rotodynamic pumps. These pumps mainly works on the centrifugal force, and these pumps flow depends upon the external circuit resistance. See, these pumps mainly depends upon centrifugal force. General example of these are centrifugal pumps. In this, the vacuum is created at the center of the pump called as eye, and the material is pushed out of this eye to the external casing. So in this, the metal is pushed from center to outside. This is called a centrifugal force. So the material pressure is getting increased due to the presence of the veins, and the veins, the metal is being transferred through the veins due to which force? Centrifugal force. That's why the rotodynamic pumps main principle is centrifugal force. So generally the rotodynamic pumps are centrifugal pumps. Positive displacement pumps. These pumps transfer a certain amount of material in each revolution of pump and continuously pushes the fluid to the delivery side. In the previous pumps, rotodynamic pumps, the pump's flow depends upon the external circuit resistance. Means external circuit resistance means when the external side pressure is more, these rotodynamic pumps flow decreases. But in case of positive displacement pumps, these pumps continuously transfer the fluid irrespective of the delivery side pressure. So these pumps just generally transfer the material from suction to delivery. That's all. So general examples of these are gear vane low pumps. Positive displacement pumps, another definition is that these pumps will transfer a fixed amount of quantity in each revolution of the pump. These are like pushing pumps. They will take the material, they will deliver the material. These two types of pumps are like broad classification because every pump has its own internal construction whose working principle will be varying. The main principle will be these two only. How will be I will be taking you to some of the videos regarding pumps. See, the left side one is a rotodynamic pump, the right side one is a positive displacement pump. See, the left side one is a example of centrifugal pump. The suction is at the center of the pump and delivery is at the circumference, means at the periphery of the pump. Due to the centrifugal force, the pressure is getting builded. I also said that the impeller vanes are responsible for increasing the pressure energy. The material enters at the center of the pump and it is delivered at the periphery of the pump. See, I already informed you that the pump's flow increases when external circuit resistance decreases, when external circuit resistance increases. Like whenever the valve has been closed, the pump flow is very less. When the valve is getting open, the pump flow is getting increased. So the pump flow depends upon the external circuit resistance. So this is an example of rotodynamic pumps. This is an example of positive displacement pumps. In this, the material will be transferring from this side to this side. This is the pump's main working principle. This is an cam-like design, internal eccentric shape. So in this, these vanes will be sliding in this slotted part. So when the material is getting entered, when the vanes are coming out of the slotted parts, the material is getting entered into the cavity between the two vanes and they are getting pressurized due to the internal eccentric shape and are being delivered to the delivery side. That means the material, when the vanes are coming out of the slotted part, the material is getting entered into the spaces between the two vanes and the pressure is getting builded by the internal shape of the pump. Like the pump is not fully circular, it is like eccentric, means the pump internal design itself increases the pressure. As I already informed that this is generally used for pushing the material. It will be sucking this material this side and it is pushing this material to this side. See, one another interesting topic in this positive displacement pumps is that this contains an special device called pressure safety valve. So this pressure safety valve will protect the pump from blasting. Means when the delivery side pressure is increased, the pipeline will get burst. So because every pipeline has its maximum pressure limit and maximum temperature limit. So this pressure safety valve is a safety device which protects the pump and the pipelines from damage. So what it will be doing is that when the material is getting entered into this side, it will be flowing this side and flowing this like this. So in case of pressure is getting increased in this side, so it is more. So what it will do, the material will be generally entering into here. The material will be generally entering from here to here. Again it will be following the same path up to here. And but here what the path it will follow, it will directly go from here to here, here to here and here to here. Again it will be coming to the suction side. So whatever the material it is delivering, again the material is getting delivered to the suction only. So there is no pushing of fluid to the delivery side. So in this way the pump is safety and pipe safety has been ensured. So you got to understand that this is from this side it will be going to this side. Metal will be coming this side. Okay, then after we'll be discussing about how to select a pump. We are having a certain purpose. How to select a pump? Which factors we have to consider for selecting a pump? So we'll see how to select a pump. There are a number of factors to be considered for selecting a pump which suits our demand. Material of construction means the material of construction which defines as the material of construction of internal working mechanism, the pump outside casing, everything. Depending upon the type of material to be transferred, pump MOC can be decided like MS or SS. See, type of material to be transferred. See, if you are transferring less corrosive material or higher corrosive material, the pipe strength and the pipe corrosion resistance, and the pump internal material corrosion resistance also should be more to withstand the corrosion of the material. So generally we will be considering the pH material to decide the pump MOC. If the pH is acidic, then the material is more corrosive. If the pH is basic, it is less corrosive than acidic materials. So pH of the material is acidic means we will be generally using SS316 stainless steel 316 grade. If the pH of the material is like basic, like 8 10, then we will be using like SS304 or MS. We can be using these two type of materials. NPSH, net positive suction head. Net positive suction head. See, do you already know cavitation is a process in which when the suction pressure is below the vacuum pressure of that fluid, boiling of the liquid will be occurring at the suction side, which in turn damages the pump internal casing. So what we'll be doing is that we will be increasing the suction pressure above the vacuum pressure so that no cavitation will occur at the suction of the pump. So every time NPSH has to be considered for selecting a pump also. Friction head means this pump material will be transferring to a number of pipes, bends, different in cross section, reducers, expanders. So the friction means the pressure energy will be losing due to the pipe internal friction and also due to the pipe sudden bends, sudden reduction in cross section area. So frictional head also has to be taken care while considering the pump. Static head means it is the static height difference. If the pump is at ground floor, if the delivery is at the second floor, this is the vertical height. But friction head will be considering about the piping arrangement. So total head is the sum of friction head plus static head. So flow rate. So this fluid has to be transferred to that area like 1 kg per second or 1 meter cube per hour or 1 liter per minute. So based on flow rate also we will be deciding the pump. So we have seen about the different factors. Now how to select a pump very easily. Now we'll see pump curves. See, pump curves are very easy for selecting a pump of our demand. See, the left side curve is of, it is a pump curve between the discharge and the head required. See, this is a 7-inch impeller, 7.5 inch, 8 inch, 8.5 inch, 9 inch, 9.5 inch impeller diameters. So this is the power 5 HP, 7.5 HP, 10 HP, 15 HP, like it has been mentioned. So this 7-inch pump consumes 5 HP horsepower. So if you want to get 200 flow rate, it can deliver up to like 45, 48 like that. It can deliver up to 45, like 45 head means 45 feet. It can deliver 200 gallons per minute. So it can deliver 100 flow rate, 100 gallons per minute at 48 head also. So when the flow rate is getting increased, the head it can develop also it is getting reduced. So based on that, if you want to compulsorily deliver 600 head at 65 pressure at 55 feet, so then what we have to select? Compulsory we have to select what? We have to select an 8.5 inch impeller size diameter of the pump. So the second curve is about the relation between the power, height and the flow. So if the flow head is common, like 1 meter head is the common, but the flow is getting increased. For 10 meter cube per hour, what is the power required? It is the power between 0.01 kilowatt to 0.1 kilowatt. So if the flow is getting increased to 100 means the power required will be, see how much? It is between 0.1 to 1. So it is a graph combining of three: power, flow and height. So from this we can get the power required, and the flow we are selecting and the height we're selecting, we can directly get the power. In this what we're getting? We are getting the impeller size. In this where what we are getting the power required for the motor. So friends, thanks for watching my video. Please do like and subscribe. If I want to make any videos regarding your wish topic, please do comment.